Good morning, everyone. I'm Jun Yang. I'm here to give a lecture about the gyroscopic precession. This linear chair is using the principle of the gyroscopic precession. What is gyroscope? In Greek, gyro means round, scope means to look. This gyroscope includes a frame, gimbal, rotor, and spin axis. Precession means a change in the rotation axis of a rotating body. So the orientation of the rotation axis is changing. Why do we learn gyroscope? Because we can understand the principle behind the phenomena, so you can use them in our application, for example, in the aircraft, even your own body to maintain the balance, as well as the gyro compass and the gyroscopic chair. So this picture shows the gyroscope is used in the International Space Station. When we ride a bike, the bicycle wheels also have an angular momentum. And the Earth is a spinning body which also uses the principle of the gyroscopic precession. The basic principle of the gyroscopic precession includes the direction of the angular momentum. It's different from the direction of the external torque. The angular momentum is swayed by the external torque. The angular momentum and torque, they are vectors, direction. For example, the force and velocity, they are also vectors. The angular momentum L equals the radius R cos m over v, the momentum. The R is the radius, m is the mass, v is the velocity. The torque equals the radius cross external force. We can use the right-hand rule to decide the direction of the angular momentum. So the four fingers towards the direction of the rotation. The direction of the thumb is the direction of the angular momentum. Accelerations change direction of motion. A constant circular motion requires a centripetal acceleration of change in the direction of the velocity. If this is the original position, this is the radius r, and this is the original momentum. And later, this new r, and the new momentum is shown in the solid line. So the red shows the change of the acceleration, which is the change of the velocity divided by the delta t, which is also equal to the force divided by the mass. Here we can see the demonstration of the gyroscopic precession. So it is spinning and also show precession. And later we will show the physics behind this system. Similar as a bicycle wheel. And here we can see the system, the angular momentum is showing in the green line air, and the torque is R cos F. So the R is in this direction, and the external force is mg. So the torque is pointing towards us, which equals the change of the angular momentum divided by the delta t. So the change of the angular momentum equals the torque times the delta t, and this is the original angular momentum, this is a new angular momentum. So this is the change of the angular momentum. And if we use the system from above, so you can see the air, this is a new angular momentum. So this is a change of the angular momentum, delta air, and torque is delta air divided by delta t. So the whole system is changes of orientation. So there are many applications about the gyroscopic precession, even in the astronomy, the rotation of the Earth's axis relative to the celestial pole is shown in this figure, and there are many other spinning objects includes the other stars also change their orientation due to external torques. About the pulsar, and so far we talk about the gyroscopic precession, the principle and the application. Can you think of any other system that also uses the gyroscopic precession?